means for a figure, a shape, or a triangle to be similar. Let's look at the definition of what it means for triangles to be similar. So similar triangles are triangles that have the same shape but not necessarily the same size. And dilation is the only sort of transformation that can create similar figures because it changes the size but it doesn't change the shape. So you're not going to dilate a square and get a rectangle. You're not going to dilate a triangle and get a square. Same shape, but it can be different size. But the thing about the size is important. And down here it says that similar triangles always have corresponding angles that are congruent. So congruent meaning the same. So the angles are congruent. So the angles of the dilated shape are the same. So angle A is the same as angle B, has the same measure as angle D, and angle B has the same measure of angle E. So the angles don't change, but the corresponding sides are proportional. And that's how we get the scale factor, right? We multiply by a set number for each of our sides. So the corresponding sides are proportional. So now let's take a look at what that looks like not in theory. So again, like I said, this angle that corresponds, angle A corresponds to angle D. So the angle measures are congruent, they're the same. But the side lengths, like side AB, that corresponds to side DE, they're not congruent, but they are similar, right? We multiplied by a half. Okay, and here again, we multiplied by a half. And we multiply it by half. So the side lengths are proportional, but the angle measures are the same. So that is necessary in order to determine if two shapes are similar. You have to look at both the angle measures and make sure that they're congruent, and the side lengths to make sure that they are proportional. That's the definition of any figures being similar. So now let's take a look at some examples. So this says, are these shapes similar? So first we need to take a look at the angles. So I see two angles that have two lines and one that has one. And in this shape, I see two angles that have two lines and one that has one. So I am noticing that the angle measures on the interior of the triangle are congruent, right? Now we have to figure out what sides correspond to what sides, and then determine if the scale factor is the same for all of those corresponding sides. So if we can imagine that we turn triangle VTU or whatever it's called, right? We turn it so that way it's oriented the same as triangle ABC. We would have our 2 here and our 1 here, right? So this would be angle V because that's where our angle with the 1 line is. And then we would have, I gotta use my imagination, U and T over here. Okay, so we just kind of rotated it, and that's okay. You can have multiple types of transformations on a figure. So it can be a dilation and a rotation and a reflection, right? So we just have to kind of use our imagination. So now that we've rotated it so it's oriented the same, it's a little bit easier to see. So this side VU, we said was 20. And we can kind of tell that VU would correspond to BC. So now let's see what the scale factor. So what number are we multiplying 30 by to get to 20? That's the question that we have to ask ourselves. So if we write that using algebra, right, we're saying, well, 30 times what number X would give us 20. So in order to solve this algebraic equation, we would want to create a 1 pair. So if we divide both sides of our equation by 30, 30 over 30 is 1, right? And then we're left with, well, X is equal to 20 over 30, which we can simplify to 2/3. So now we know that in order to get from here to here, we multiplied by 2/3. Okay, let's see if that's the same for all of our sides. So let's identify another corresponding side. let's go from here to here, right? So that side, TU, has a measure of 14, and then we have another 20 over here. So in order to get from 21 to 14, well, what did we multiply by? Well, let's do it again, right? Well, 21 times what number would give us 14, right? And again, if we divide both sides of our equation by 21, we would create a 1 pair. We would get x is equal to 14 over 21. Now I know that both of these are divisible by 7 as our greatest common factor. So we'd get 2 over 3 again. Okay. Right? So again, we multiplied 21 times 2/3 would give us 14, and you can check that in your calculator. And you would want to go ahead and check the last side just to make sure. So to get from 30 to 20, what did we multiply by? Well, maybe you're seeing the pattern, right? We would just do 20 divided by 30, which we kind of already said here was 2/3. So we know that we multiplied by 2/3. All right, so we've just determined that our side lengths are proportional. We multiplied by the same scale factor for all of our corresponding sides, and we know that our angle measures are congruent because they're labeled as such. So the answer for this problem would be yes, these two shapes are similar. All right, so let's take a look at another one. So here we're looking again, the easiest thing to look at first is to identify, are our angle measures the same? So I see two corresponding angle or two congruent angles here. They're labeled the same, so that means that they're congruent. I see 2 dashes here, so those two angles are the same, and 3 lines here, so those two angles are the same. So we've already established that both of our triangles have the same interior angles. So that is a check, right? Our angles are congruent. So now we just want to figure out, is the scale factor the same for all of our corresponding sides? Well, we need to first, since these are oriented differently, I'm going to go ahead and redraw angle QRS so that way it's oriented the same as EFG, right? So it's a little bit bigger. So I'm going to draw it as similar as I can, like that, right? And we have this 3, and we have 2. So where we had 2, we had an S. Where we had 3, we had our Q. Where we had 1, we had our R. Okay. So let's see. From QR, we called QR, this line, they said that was 20. We said that SQ was 30. And we said that SR was 40. Okay, so now we have our triangle oriented the same. So now we can compare these two triangles. Okay, so we want to determine, is our scale factor the same? So let's take a look at FG and SQ, right? So let's take a look at the blue sides of our triangle now. So we want to know, what did we multiply 18 by to get to 30, right? Times what? Well, 18 times what number, x, right, an unknown, is going to give us 30. So let's go ahead and solve this algebraically. That creates a 1 pair. We just have x is equal to 30 over 18. And I know that both of these numbers are divisible by 6. So we get 5 over 3, 5/3. Okay, so here we multiply by 5/3. All right, so let's see if that's the same for our green side. Let's go ahead and do green. So here, this side. So what did we multiply 12 by to get to 20? So we can, hopefully you're seeing the pattern here. I'm just going to go ahead and do 20 divided by 12. That'll give us the multiplier. Right? Well, 20 divided by 12, both of these numbers are divisible by, well, I know they're both even, so at the very least they're divisible by 2. So let's start there. So we get 10 over 6, and 10 over 6, well, those again, 2 even numbers, right? So I can divide that and simplify that fraction even further to 5/3. Well, we get 5/3 again. So let's take a look at our last and final side, our red side. What did we multiply 24 by to get to 40? So again, 40 divided by 24. I know that both of these are divisible by 8 actually, right? 8, 16, 24. Yep. So let's divide them both by 8. That's the biggest number I can think of right now, but I'm sure we'll figure it out, right? So 40 divided by 8 gives us 5, and 8, 16, 24 is 3. So again, we multiply by 5 over 3. So we have established that our angles are congruent and our corresponding sides are proportional because we multiplied them by this all by the same number to get our image, right? A dilated triangle. So the answer for this, are these similar? Yes, they are. Okay, by the definition of similar figures. All right, are these shapes similar? Well, the easiest thing to look at is the angles. So I see a 1, 1, and a 2, right? And I see a 3, a 2, and a 3? No, a 4. Okay, so obviously the angles are not congruent, so these two shapes are not similar. And again, right, the interior angles of these two triangles are not congruent, right? These are all the same angle. All the shapes on the interior of this angle are similar, but the angles on the interior of this triangle are not similar. Also, you can look and see that the side lengths of a triangle PRQ are the same, and if it was dilated, even if it was dilated, maybe bigger or smaller, the side lengths would still be the same. Okay, they would either just be twice as big, but all the side lengths would still be the same if they were scaled up or scaled down proportionally. So again, these two figures are not similar.